Hi viewers, this is Indumati, Assistant Professor, Department of Mechatronics Engineering, here to present you the topic of Programmable Control Instructions from Programmable Logic Controllers, that is PLCs. Let us enter into the topic. So, what do you mean by Program Control Instructions? Those instructions which are capable of alter the program scan from its normal sequence, which are called as program control instructions. Actually, the program can be executed usually in normal stage by stage or step by step or line by line only. But some of the instructions can have the power to alter the sequence of the program. If it is executed line by line means when it sees the jump instruction, it immediately jumps to the particular destination. So the jump instruction can have the power of skipping these instructions and directly will jump into the destination. Like these instructions are called as program control instructions, which can be able to control the sequence of the program. So this is a hardwired master control relay circuit. So MCR, we are generally call it as MCR. MCR is nothing but master control relay circuit, which has master stop and master start button, and it is within this run only the MCR circuits are operating. This master control relay will control all the elements inside the PLC ladder diagram. This is the specialty of master control relay circuit. This is the master for all other runs in the PLC circuits. Next one is MCR instruction, which is nothing but the master control relay circuit instruction, which can be programmed to control an entire circuit or to control only the selected runs of the circuit. Where you need to control the runs, you can fix the MCR instruction there. From the run itself, it is under the control of that MCR instruction. So from that run to which run you need to control, you can fix the another end MCR instruction there. From there to there, it is under the control of MCR instruction. So when the MCR instruction is false or de-energized, all retentive non-latched runs below the MCR will be de-energized even if the programmed logic for each run is true. So this is the sample program for MCR instruction. If you are seeing here means this is on off switch. So the on off switch is connected to the MCR run. So when MCR get energized, once the on is switched on, and immediately these runs under the control of MCR, start, stop, motor, pilot light, solenoid valve, everything will be working under the control of MCR. Once this is on only, then only everything will be get on, and this is the end MCR run. So within this supervising only, these runs will be working. This is the sample circuit for an MCR instruction, how to control the entire circuit. And this is the MCR fenced zone. This is, we call it as fenced zone. The master control reset instruction is used in pairs to disable or enable a zone within a ladder program and has no address. You can program the first MCR with input instructions in the run and the ending MCR without any instructions in the run. So this is MCR zone true. This is active MCR start fence. Here, whenever the input is energized here, immediately your MCR will be activated. Once the MCR is activated, these runs, timers, output, input, everything will be controlled under MCR, and this is the end fence of the MCR zone. So these runs are between start fence and end fence, which zone is called as fenced zone. This is the sample program of a fenced zone, which is caretaking by the two MCRs, that is start fence MCR and end fence MCRs. Hope with this diagram you can understand better about the MCR instructions. So the programming MCR instructions, if you start instructions such as timers and counters in an MCR zone, instruction operation ceases when the zone is disabled. The timer of will activate when placed inside a false MCR zone. When troubleshooting a program that contains an MCR zone, you need to be aware of which runs are within zones in order to correctly edit the circuit. MCR controlled areas must only contain two MCR instructions, one to define the start and one to define the end zone. And the next one is jump instruction. As the name the jump instruction is an output instruction which is used for the purpose of able to jump over certain program instructions. The advantage to this jump instruction include the ability to reduce the processor scan time by jumping over instructions not pertinent to the machine operation at that instant. The PLC can hold more than one program and scan only the program appropriate to operator requirements. Sections of a program can be jumped when a production fault occurs. This is the symbol of the jump instruction, and this is by using this diagram we can easily know the operation of the jump instruction. So let us see here the program scan is done sequentially. One by one, the run by run, it is sequentially the program scan is done. Once it sees the jump instruction, immediately it skips the blue color runs and immediately it jumps to the destination address which we mentioned in the jump instruction. Immediately the jump will go to the destination address. Jumps are normally allowed in both the backward and forward directions. Jumping over counters and timers will stop them from being implemented. We can even jump from timers and counters also. So jump to label. So jump to the destination is also possible. Jump to the label is also possible. So with Allen Bradley PLCs, the jump instruction and the label instruction are employed together. So the scan can jump over a portion of the program. The label is a target for the jump. It is the first instruction in the run and it is always true. A jump jumps to a label with the same address. The area that the processor jumps over is defined by a locations of the jump and label instructions in the program. This is the sample program for jump to label. This is push button 1 and push button 2. Whenever we press push button 1 and push button 2, immediately the motor will get on, and after that the pressure sensor detects within the timer limits, time base value. Immediately our pilot light will glow. It sees the jump instruction here. Whenever it sees the jump instruction here and the destination label is here, this blue color is the destination label and 1 is the jump instruction. So it skips 5, 6, 7 and it directly jumps to the label part and automatically it starts scanning from the next rung itself. This is the sample program for explaining jump to label. Hope you understand with this diagram. And see here, when the input is given, it jumps to the label 20. Immediately it jumps to the label 20 by skipping these rungs, and immediately it jumps to here label, and if it executes again it sees the jump here, means this jump also again will come to the label of 20 here. We can have 2 jumps in a program. Next one is jump to subroutine. First we have seen about jump to label, and now we are going to see about subroutines. First, what do you mean by subroutines? Means the program which is repeatedly used in the main program can be written as a subroutine in the sub area, that is main memory or sub memory. And whenever we need that subroutine, repeated instruction which are used in the main program can be written in the sub area. Whenever we need it in the main program, we can call that subroutines to the main program. This is the concept of main program, subprogram. So the that is which we used subprogram in the C and sub VAs in the lab view. Likewise, we are using subroutines in the PLCs. So these subroutines can be whenever required, we can call it in the main program using the instruction JSR, jump subroutine, and immediately whenever the scan see the instruction JSR, jump to subroutine, it immediately goes to the area subroutine here and executes sequentially. Whenever it see the return, unconditional return or conditional returns are there, whenever it sees the return instruction, immediately it return backs to the next instruction from the JSR program. So this is the simple operation of jump to subroutine. So jump to subroutine, SPO file number we have to mention here. To the subroutine, immediately the jump can be done to the subroutines. So this is setting up a subroutine file. So JSR SBR file number 3. Whenever the run sees JSR, it immediately go to the file number 3. The program executed sequentially. Then again it will return back to the next run to the JSR run. This is the process here. Passing subroutines passing subroutine parameters to the subroutines is optional. SBR instruction is the header instruction that stores incoming parameter. This feature lets you pass selector values to a subroutine before execution, so the subroutine can perform mathematical or logical operations on the data and return the results to the main program. And here we have to passing subroutines like this. Input parameter n7:30. This input parameter is n7:40 and n7:30 will be mapping here, and the data in the n7:30 is passing to n7:40. The process, whatever addition, subtraction, whatever the process we have to done in the subroutine, that will be done here, and the result output is stored in n7:50. That n7:50 is given as the return parameter, that is output parameter to n7:60. The output is stored n7:60 in the main program. So the parameter is returned back to the main instruction n7:60. The output n7:50 will be sent to n7:60. The next execution can be done from the next run of the JSR. Next one is nested subroutines, which can be explained very well through this diagram. The nested subroutines means from the main program we are calling one subroutine. In the subroutine itself we are calling again the jump to subroutine, again another subroutine. From this subroutine itself we are calling another subroutine. And this concept is called as nested subroutines. See here, this is the main program. This calls the SBR file number 3. So immediately this subroutine is it went to the subroutine, and when it is executed sequentially, it sees the another jump to subroutine. This file number is 4. Immediately it go to the next subroutine file number 4. Again it is executing sequentially. When it sees subroutine file number 5. Immediately it go to the subroutine file number 5. So here super good, no subroutines are there, so it sees only return. When it sees return, it return back to the next run off from the JSR, and when it sees the executed sequentially and it sees the return, it again return back, and when it sees return, it again return back to the main program. Likewise, the nested subroutine concept can be done in PLCs. Hope you can understand better about program control instructions like master control reset, jump, jump to label, jump to subroutine, nested subroutine concepts in PLC. Thank you viewers, thanks for watching. Keep learning and keep growing. If you have any doubts, please post it in the comment box.